This is part two of our interview with Andrew White, CEO, and Mark Korol, CFO of Char Technologies, yes, on the Venture Exchange. We are doing our deep dive into the company and markets and answering questions from our audience. If you find these interviews useful, please subscribe to this channel to see the latest videos and interviews. And I'll start off with, can you walk us through kind of what goes in, just like you've talked about it, but simply like a bunch of wood chips or bio stuff goes into the front, you heat it to a high temperature without oxygen, and then you get gas and biocarbon out the other end? Or is it that, did I get that right? Or do you maybe get a little more complex?
It's pretty much is that simple. We feed in different materials. So if it's the wood, we'll do some pre-processing to make sure it meets a certain size spec. If it's biosolids or digestate, we may do some pre-drying. Any drying we do is run off of waste heat because we do generate lots of good heat for that. It goes through an airlock, so we keep all the oxygen out. It goes into this kiln, and the kiln really, at a very simplistic level, is a rotating tube with a couple of what are called lifters inside, and the material just kind of tumbles down the inside of this tube as it's being heated from the outside, so heated up to 800 degrees Celsius. And so the combination of no oxygen inside the tube and the kind of the flame, the heat being applied outside the tube means that nothing inside is burning. You always need, oxygen to burn stuff, and you need flame to kind of ignite it. And so both of those are kept outside of the kiln heat tube. So what that does is, again, it thermally breaks it down, and we have what's called fixed carbon and whatever ash components coming out as a solid. And we can change the operating conditions of the kiln to kind of optimize either the carbon or the gas production, how we want the gas to look, how we want the carbon to look. We can change the qualities of the product yields as part of our kind of proprietary recipe book, if I can use that term. And then, the gas will come out. As it comes out, it's called a syngas. So it's a mixture of hydrogen and carbon monoxide. And then with that gas, we can further increase the hydrogen quantity through another processing step, or we can put the hydrogen and the carbon monoxide together to create methane, which is the renewable natural gas, through a separate process. And that process, called methanation, has been used in the oil and gas industry for 50, 60 plus years. It's pretty well established because syngas is a very well-known and well-established gas in that industry. They're just used to making it out of oil and gas products, and we're making it out of wood and sewage sludge.
If I remember sort of my history correctly, to make charcoal back in the medieval ages and stuff, they'd get some burning wood, throw it in a big pit, and then cover it up with leaves and soil, and it would kind of smolder there without oxygen. You're basically making a high-tech version of charcoal. Am I? And then I guess back in the old days, the methane or whatever would just gas off into the atmosphere, and they didn't know what to do with it, or they didn't know it existed probably, and they'd end up with charcoal. Is that basically what you're doing?
That's basically what we're doing. The only slight difference is when they covered it up and it smoldered, there was always still a little bit of air getting in. That air was burning the syngas, the methane that was coming off, to create enough heat to keep the smoldering going. We've completely separated those pieces, but essentially our tube is that pit that's covered up in whatever it's covered in to keep most of the oxygen out. We've just made sure all the oxygen stays out. And that, of course, gives us control, and we can really tune and refine what products we want to make.
Given that core technology is pretty old, what kind of patents or IP or what can you do to protect your sort of market share and hopefully dominance in the space?
Yeah, our IP is all around the recipe book. So if you look at our high temperature pyrolysis kiln as a oven, we have some internal knowledge, some trade secrets around what we're doing and what we've done to it to ensure that we're keeping oxygen out, to ensure material flowability, to ensure heat transfer in and out of it, which is all really important stuff. But our core IP is the recipe book that goes along with the oven. So What ingredients are we putting in? What operating conditions, times, temperatures, environment within the kiln are we creating to optimize either hydrogen and carbon monoxide, biocarbons that are good for the steel industry versus good for soil amendment versus good as an activated carbon replacement. All of that is kind of really where our magic and our IP resides. And the patents that we do have in our portfolio are all around that input process to output recipe book.
So other people could do the basic process, but presumably with your patents that they wouldn't be able to do it as good or efficiently or as focused to like, you want exactly this recipe, or I guess you tune it for firstly for what output you want, and then also tune it for what kind of input is. Because if you're taking cow poop or lumber bits, probably a different kind of process or input recipe to manage that.
Absolutely, exactly. Yeah, we need different conditions for the different feedstocks and for the different outputs of what we want to make. And like I said, there's some kind of trade secrets that we've developed around how to efficiently move material through the kiln, how to efficiently get our heat transfer that we want to see. The risk in kind of publishing those patents is, obviously disclosing what that process is. And when it comes to mechanical IP, sometimes it's a little easier to get around the IP fence if you want to kind of innovate around it. Whereas we certainly feel the recipe book's a lot stronger IP fence. So that's the IP we want to file and couple that with trade secret aspects. And of course, if you look at the history of pyrolysis, it's been around for a little while, and there's some very important reasons why previous pyrolysis technologies struggled at the commercial scale, whether it was they were focusing on the wrong product outputs or they were operating at really the wrong conditions to ensure that we're getting these optimal outputs.
All right. You talked about your process being carbon negative. Explain how it's carbon negative.
Yeah, absolutely. So, the general concept is of kind of the terrestrial carbon cycle, if I can. So, we've got CO2 in the air, and it gets taken up by plants, either by trees to grow the tree or by corn or whatever products that we eat, and then ends up in the wastewater treatment plant sewage sludge stream. So in both of those cases, the carbon is then coming to our plant. We're pyrolyzing it. The syngas that's coming off, part of it we're putting into the kiln itself to drive the heat. So we're not having to use, natural gas or other fossil fuels that are, nicely stored underground. We're just using stuff that's always been, above ground here. And then the outputs are either carbon neutral. So if we're producing a product like Clean Fire, where we're offsetting coal, it's still producing some CO2, but again, it's all above ground. So it doesn't count from a greenhouse gas perspective. So that's the neutrality part. The negative part is when we're producing things like green hydrogen and renewable natural gas, and that biocarbon is used as a activated carbon, or it's used as a plastics filler, or it's used as a soil amendment product. Anything where it's now being fixed into the ground, essentially what we're doing is a type of carbon capture and sequestration, because we're indirectly through plants or other biomass capturing CO2 from the atmosphere, stripping off some energy, natural gas, hydrogen, and then the remainder of the carbon gets fixed in the ground. So that's where we have either the carbon neutral if we're producing a biocoal, or a carbon negative if we're putting that biocarbon into the soils or into other products where it's fixed in the ground level.
All right. You mentioned first and second generation, like from the renewable natural gas, the ZBECs of the world. Do you actually compete with them, or are they just sort of, they have one segment of the market, the cow poop and that, and their bioreactors, they do that, and you just have a different segment that they can't capture? Or could you go after their market, but they can't really go after your market? Is it something like that?
Yeah, I mean, it's definitely more of a, we're parallel slash we can actually collaborate on something. So, but at a high level, on the output side, on the market side, the kind of thirst for renewable natural gas is so high that we really will need all solutions to get us there. So, we don't see, say Zebeck's building a biogas plant. They're not going to get a contract for RNG to our detriment that we now can't sell RNG because there's just such a demand for it. So then the other piece then is feedstock. And like I said, we're looking at woody waste, biomass waste, which cannot go into those biogas plants. I mean, it can, but nothing's going to happen. It'll go in, it'll come right back out. And that's the area that Zebeck is focused in. And their technology, their kind of core is a biogas plant produces methane and CO2. That goes through their PSA, and now they've got nice, clean methane to use as renewable natural gas. Our kiln produces hydrogen and carbon monoxide, which we then take through a methanation process. So the kind of pathway is different and the feedstocks are different. Now, where there's potential collaboration is, you may recall earlier in the slide presentation, I was talking about these biogas facilities, these first generation renewable natural gas plants produce a solid output akin to a compost or a biosolid. It's kind of a fibrous material. And that comes out because it's what the bacteria inside those biogas plants couldn't eat. They can only eat very specific foods, and then they're left with this fiber. That fiber is what could go into our kiln system. So conceptually, you could have a biogas plant that's, say, built or Zebeck is providing the gas upgrading system, and it could have a Char high temperature pyrolysis unit co-located, consuming that last little bit of digestate and producing, say, additional green hydrogen on site. And I want to give Mark an opportunity because he's got a very favorite analogy here that I'll let him take you through for that.
Yeah, this is sort of the layman's analysis, non-technical. Zebeck and Green Lane, they take the orange, they squeeze the bulk of the juice out of the orange, and they create RNG from that process. We take the remainder of the orange, including the peel. That peel we put in our pyrolysis. The pyrolysis becomes it creates the bio coal out of the orange peel, and then the remainder of the juices get converted into either RNG or the green hydrogen, as Andrew has explained on a technical basis.
All right.
That's how I understand it.
Andrew, with your process, you have like the carbon monoxide and the hydrogen comes out of your process. Are they in sort of the appropriate ratios? So, or do you have some, or do you have any excess waste product that you don't know how to use, or you have to store it or destroy it in some manner, or is basically everything coming out of your system fully used?
Yeah, basically everything in the system is fully used. So we can do some optimization in the kiln to get the right carbon monoxide hydrogen ratio. We can do additional process steps. So, like I was saying with methanation, there's another well-established technology called a water gas shift reactor, which actually allows you to convert carbon monoxide into hydrogen, into additional hydrogen. And then much like, if we go back to the biogas example where, you're purifying methane, in our system, when we purify our hydrogen or we purify our renewable natural gas, the leftover gas is what goes back and fuels the kiln itself. So we're able to use both of those streams to both run the kiln for the temperature and extract all the excess gas. And then, of course, the biocarbon is what's left over, and that's where we have our markets like our biocoal opportunities.
With the hydrogen, if you want to just stream off the hydrogen and use it for the hydrogen economy, what do you do with the carbon monoxide at that point?
So yeah, so that it's maybe not well understood, but carbon monoxide actually has energy value. You can burn carbon monoxide. So that carbon monoxide stream will go to our kiln burners. It'll be combusted and generate the heat we need for the system.
Oh, okay. Oh, I never knew that. Okay, going to the business model itself, how do you see, like, are you going to be building out your own facilities? Are you going to license out the technologies, joint ventures? I'm kind of guessing it's probably going to be a bit of everything. Can you sort of talk about how the commercial economic model is going to work?
Yeah, and it's kind of bang on that it's a bit of everything. So and it's really a bit of everything depending on the market segment. So when we're looking at opportunities in the woody biomass to renewable natural gas, that's such a blue ocean opportunity that we'll be doing the whole thing. So we'll have the plant, we'll have the offtake contracts, the long-term offtake contracts from the utilities for the renewable natural gas. We've talked to JV partners for those projects where the JV partner brings specific expertise, like long-standing operational kind of excellence, because operations are such a critical part of the overall process. And so it depends on which partners we bring to the table for feedstock supply or operations and operational support. If we own the whole facility, we would end up contracting out operations in that case. So there's a little bit of flexibility there, but we would be the primary owners and the primary beneficiaries of these long-term stable RNG offtake prices that really builds that recurring revenue, which we like to see. The second avenue is looking at, we'll be a little more specific, but say green hydrogen from anaerobic digestate. So this is an established biogas facility. It's making RNG. It has excess digestate. So in that case, again, we will look to be JV partners on the asset, but that's much more clear that that facility is running the operations because it bolts on to their end. And as partners in it, we will receive some of the revenue from the green hydrogen. But we don't have to worry about doing the project development, the permitting, the land acquisition, the contract negotiations, that's kind of established. The feedstock's there, the operations is set by them. And then the third model would be where, especially when we look at the biosolids processing, where the key driver is the destruction of this PFAS compound, where that's such a mature market, the biosolids processing market. There's some very well-established players. So in that market, we would primarily be a technology vendor, sort of turnkey our scope of delivering a pyrolysis plant, get that nice, initial revenue bump. And depending on how that company operates, we may have an opportunity for some recurring revenue from the offtake. So if they don't know the hydrogen economy, we can take a management fee on the hydrogen. If they don't know the soil amendment biocarbon market, we can take a management fee on that piece. But that'll be a little bit more individual because each of these companies operate slightly differently. So we kind of have to adjust our model based on sort of the established partners, what the market looks like, and kind of how we best fit those different market opportunities.
You mentioned I think you said 25 million to produce half a facility that would produce either a million or half of a million of a gigajoules of natural gas, and then 25,000 tons of bio coal. Correct me where I got that wrong. Are those basically the economics of it, or is that sort of what? And did I get that right? And what would the economics be on that? What kind of margins or profit would you get off of that?
Yeah, so kind of back of the envelope, that plant would be about $25 million capex, producing 1 million gigajoules and 25,000 tons per year of biocoal. We can assume kind of an RNG price of $20 a gigajoule. We certainly have seen some higher. I think that's a reasonable assumption because certain utilities have a $30 price cap, so that gives lots of room. And the demand for RNG is going up and the prices are going up. So if we use $20 a GJ, that gives you the revenue stream from the RNG piece. And then the biocoal piece, realistically, it's going to be in the $250 per ton range at the outset. Because of the greenhouse gas pricing, there'll be certainly some mechanism in place that we get some additional benefit as the GHG pricing goes higher and higher. But $250 a ton is a good starting point on the revenue piece. And I'll let Mark kind of finish off the puzzle for us. But I think the important piece is in this model, we are the project developer. So we're not looking at CapEx margin. We're looking at ongoing operational margin.
Yeah,
Okay.
so that gets us revenue on the 25 million of CapEx at around 25 million, depending on the assumptions. And the margins are going to be conservatively 70%, realistically 80%. So we're getting paybacks, and this is without any government subsidies, grants, carbon tax credits. We're getting paybacks of, let's call it, I want to round up here, let's say 2 to 3 years just to build in some cushion. But it's extremely attractive, the economics, especially in clean tech, where the economic viability is very rare.
All right. Can you, with the input costs, is that other people's waste? Can you get it for free? Do they pay you to take it off their hands, or do you have to pay them for it? And I'm guessing as bio waste becomes more valuable or gets higher demand, the price of that could start increasing. What are your input costs?
Yeah, and again, it will vary by the markets, of course, as always. So in the woody biomass, where we're taking kind of wood waste from sawmills or the like to make RNG, there is a cost for it because there are other market opportunities. It can just be burned for heat, or it can be made into pellets. So depending on the geographical location, our input cost would be anywhere from $10 a ton to $30 a ton will be in that kind of range. Again, type of product, location, because the geography plays a big part in what that pricing is. The second market opportunity we talked about, co-locating with an anaerobic digester to produce green hydrogen. Some digesters have a cost to dispose of digestates. Some are kind of breaking even. Our model assumes a zero cost for the digestate. It doesn't have to move because we're co-locating on their site. The market for it isn't really established. They're not really able to sell it, so it does reduce the liability. And as in that point, partners in that project opportunity as partners, they would see the benefit in just providing the material as it comes off their digester, and we'll be splitting the green hydrogen revenue. The third one on the biosolids piece is absolutely a front-end tip fee and a potential revenue stream on the back end. When we started doing modeling around biosolids, the do-nothing case is landfilling, and there was a $50 a ton tip fee. Now we're seeing sites in the US Northeast in particular that are seeing tip fees that are approaching and exceeding $90 a ton. So that $90 a ton tip fee could translate into revenue for those projects.
And the biosolids, and that's the stuff that has the nasty PFAS in it. Is that just they scoop up a landfill and you get my old chocolate bar and wrappers and whatever in there? Or is it more of the, like my recycling, my compost bin that you guys go through? Like, how do they sort it, or can you just digest anything?
Yeah, so the key there is that, well, I guess there's 2 points, and you actually brought up a really, really interesting one that I'll get to in a second. So the biosolids one is from wastewater treatment plant. So basically what goes down the toilet.
Okay.
And people flush all sorts of things. If you ever have the opportunity to do a tour of a wastewater treatment plant, which some of us find interesting, most people don't, I do. It's
We'll
amazing.
do a Zoom, a field
Yeah, we'll
trip.
do a Zoom tour. Then you don't have to worry about the smell.
There you go.
But often the operators have some kind of trophy case that shows all the weird stuff that's come through. Like it's just amazing what people think goes down a toilet. So that's where the PFAS in biosolids comes from. You know, it's whatever's going down the toilet. But I want to actually touch on your landfill comment, because this is actually an emerging area in the biogas space. So a biogas plant that's taking source separated organics is also going to have these same PFAS things, because you have the same issue in green bin organic waste as you do in the toilets, and that is you never get 100% compliance. People will put weird stuff in their green bins as well. And so that's going to get into the digester. It passes through the digester, no problem. But now you've got PFAS in the digestate. So kind of lagging the biosolids, but going down the same path, biosolids can now no longer be land applied because of the presence of PFAS. Digestate is still currently being land applied. That's kind of how we get rid of it. And in some cases, they charge like $10 a ton, or in some cases, they have to pay a transportation fee. But once the sort of establishment gets more and more knowledgeable about the presence of PFAS in digestate, that's going to shift these first generation biogas plant models as well, to where they're really going to want a pyrolysis unit, because now they just have this material piling up on their site because they can't contract it out to the local farmers to get rid of it because of the contamination concern. And certainly within the kind of compost biogas world, we're seeing those analyses being done. We're seeing those white papers, those research papers being done that is showing PFAS in the digestate. So it's not a today issue. 3 years from now, very, very possibly will change the economics of biogas plants.
There's talk about whatever people putting their Xanax and birth control pills down the toilet and that. Would you sort of digest and sort of destroy that stuff and any other sort of non-real bio residue from the sewage?
We would. The caveat is how that those pharmaceuticals kind of where they end up, because the biosolids are one of two streams from a wastewater treatment plant. The other is kind of the clean water. And so if they're really soluble, they'll end up staying in the water phase. If they're less soluble, they'll end up in the biosolids phase. So I can't kind of blanket statement, but if it winds up in the biosolids, 850 degrees Celsius oxygen free is a fairly challenging environment for most things to kind of not degrade and break down in.
Gotcha. And what are the scale of these systems? Like, could you put a small one of your machines on someone's farm and just have it kind of run automatically, that you just shovel it into the one end, and then you can do a giant one that's working for a big pig farm in Nebraska somewhere? How small can they scale and how big can they scale, and how much operator maintenance or activity is required?
Yeah, so we do skid mounted modules, and there's a couple benefits to doing that. One is we can build it in a factory. We can do all the factory acceptance testing. So we can basically test everything in the factory and then deliver it to site. And the commissioning construction risk around the project is much less, because we basically just need a concrete pad to place these skids on. And then we've got kind of
sorry, just to interrupt there. So if you drop one in, and if you want to double your capacity, you drop two in, and if you want to increase that again, you drop three in. So it's just sort of a parallel process. You double them, you buy double the machines.
modular
More-
systems.
Yeah, more or less, except we have 3 module sizes. So
Okay.
there's, once we get kind of we'll call it basically 1 ton per hour input to 3.5 tons per hour input, and then obviously the middle is about 2. And then you want to get, say, 7 tons per hour, you put 2 of the large kilns modularly side by side and run them in parallel.
All right. And I just have a question here. Like, how many systems do you have out in the field right now? Is it just running in your own facility as sort of the trial, get some revenues going through there? Or have you sort of implemented them out with clients or as JV partner type things out in the world?
Yeah, we've got our facility that's running, that's, say, producing our biocoal order for the steel mill. We're, I think, very close to a couple of additional projects that we're certainly hopeful will get through their final phases of acceptance and sign off, and we can start bragging about them. But in terms of reliability of the equipment, serviceability, spares availability, kind of all of these really important operator questions, the kiln technology that we're using has been modified to run biomass, but it came from the mining sector. So a kiln design that was used primarily in activated carbon regeneration and gold mining. Obviously, like I said, there's been some modifications, but the core, the heat tube, the burner system, all these package pieces are the same. And there's over 200 installations in that sector with this kiln type. So, we've obviously modified it to our own needs, and that brings in some change and potentially some deployment risk. But in terms of scale up and overall system reliability, 90% of the system has been tried and tested for 30 years, which I think puts us in a very strong position to have the ability to price out spares, to price out ongoing operational costs, maintenance costs, all of those other really, really important aspects of bringing a project to fruition.
All right. We're getting up to an hour here on the thing, so we should kind of maybe wind things up a bit. Could you, like, you've got all, like, the opportunities seem huge what you've got. What kind of news flow should we be expecting out of you in the next 6-9 months? Or when are you going to start sort of selling systems or projects and start creating revenues off of that? Can you talk about that timeline? And then as well, like, you've raised almost 7 million over the last year, so your bank account's doing pretty good. Like, how far does that take you in terms of just your OPEX, or do you need more CapEx type of financing in the future?
Yeah, so I'll take the first half, and then I'll let Mark close us out here with the financial questions. So from a news flow perspective, like I mentioned really early on, is we've got this very robust pipeline. Certainly our focus now is converting that pipeline into project backlog that we're delivering on. And within the opportunities that I spoke about, certainly there's some that are really well developed in the equipment sale for managing kind of some of these on-site wastes. There's something in kind of the green hydrogen from digestate, and on the our own systems making renewable natural gas. And so within the next 9 months, I think it's very reasonable to see us be able to talk a lot more about what those projects look like. And we're obviously pretty excited to be able to do so. On the balance sheet CapEx piece, I'll let Mark take us home.
Yeah, so Martin, in terms of the monies raised, the 7 million, we have 5.5 million. That is adequate for us if we were to stick with the system sales model. Any of these utility models are going to require capital in the ground, and because they're very attractive from a payback perspective and a return perspective, we don't want to lose those opportunities, but we also don't want to put all of the capital raised into, call it, one project. So I guess the answer, the second part of the answer is, we would go to market if we have a specific contract or specific contracts to invest in. We would favor a good mix of debt and equity, but we're also realistic in terms of our first full-scale plant in the field may require all equity or a good portion of equity, just because we wouldn't want to slow down the timing of that by having to align the the project financing lender.
And would a typical project be kind of in the 25 million-ish kind of range? Is that what a sort of thumbnail? You could have some bigger or smaller ones, but that's kind of the scale.
I think what we're looking at right now is probably a $10 million plant would be the most likely in the shortest period of time.
Yeah, and that would be, to that example I gave in the deck, that would correlate to phase one of an overall project. So that would be kind of, the 500,000 gigajoules a year and 12,500 tons of clean fire as an additional point. And when we're selling the systems, yeah, I think $10 million is the good benchmark there. Okay.
All right. And so in terms of timing, like kind of news flow this year of would 2021 be possible time scale for one of these bigger $10 million projects, or would that maybe fall into 2022 or?
I think in terms of projects falling into 2021, or at least starting in 2021, is realistic. The time to build and commission will probably push us into 2022. So particularly where we're looking at, a utility model offtake, we won't be able to kind of deploy and start seeing that recurring revenue that quickly. But, I think it's very realistic to see a couple of these projects be sort of approved and started in this fiscal.
So it fair to say that you're in advanced discussions with a bunch of groups right now?
Very fair.
All right. I just noticed a question here. The carbon credits from your systems, do you capture the economic credits, or is it your clients, or I guess depends on what model it is you're using? Can you maybe sort of flesh that out a bit?
Yeah, it depends on the business model of the three we talked about, and it depends on what we're doing with the biocarbon piece. So, we'll start at that end, and that'll kind of help understand it. So if we're making biocoal that's being burned, it's primarily our client that's seeing the benefit because they're seeing a reduction in their greenhouse gas emissions because they're not burning fossil coal. So in that point, it's very clearly our clients. When we're producing,
but but that helps on your pricing because you can have a little less pricing pressure or put a little prices higher because that into their economics, their carbon credits go into
exactly. So absolutely indirectly, we'll see a little bit when we're operating the plant. We're part owners. It's kind of the project SPV that would see the carbon credits if that carbon is going into a non-combustion source. So it's soil amendment or activated carbon or any of those applications. And certainly those markets now exist, which is great to see. And so that just adds to the overall attractiveness of the project.
And I see a couple more questions here, and as well some are coming into my head here. I presume you're outsourcing the manufacturing of these of the palletized units that you'll be shipping, and in terms of, we talked about scaling the machinery and that. What about scaling the business? Because we have a question here. Do you need to plan to hire a technical sales VP to accelerate commercialization? What else does the Char business have to add on to it as it scales up?
Yeah, I mean, primarily it's both business development and technical capabilities so that, you know, we can work on multiple projects at the same time. Fabrication is done and outsourced. So, you know, certainly, you know, potentially having to find a couple of additional fabrication shops if we get so busy that, you know, we just overwhelm our current supplier is something we're actively looking at. And we're also actively looking at where we can have manufacturing done. Certainly with the green stimulus funding that we're seeing in the US and what we expect to see now that the federal Canadian budget has been released, is there will be some by, you know, insert jurisdiction here provisions. And so we want to make sure that we know what parts we can have manufactured in various jurisdictions so that we can also meet those criteria and access, you know, the additional funding. As Mark said earlier, you know, we're not reliant on government funding, but it's sure nice to have a grant to cover half your CapEx to deploy the project. So.
All right. We should wrap it up here. That was really good. Are there any final comments or anything we missed that you want to highlight, or should we wrap it up here?
Yeah, I mean, I think this was fantastic. So I just want to, Martin, thank you for again giving us the platform and asking great questions of us. I'm pretty excited about the next 12 months for Char, and hopefully everyone watching the webinar here is as well. And you know, we're certainly excited to start bragging about some of these projects in the near term. So thank you, Martin.
All right, Andrew, Mark, thank you very much for taking the time to talk with all of us. It's greatly appreciated, and a lot of neat stuff going on there. And it's neat to see all what I find fascinating. There's no one solution for all the environmental green issues that we out. You've got there's no silver bullet. There are a whole lot of silver bullets out there hitting different parts of the market. And when I hear stories like this, it's like, hey, we've got some hope that we've got some good solutions to make the world a bit better. So thank you very much.
Absolutely.
All right. Cheers. Have a great day, guys.
All right. Thanks, everybody.
Bye.